The ball initially defines vertical motion. Again here u cos theta. Again here u cos theta. Then what is varying? So what is split velocity? So what is its component along x-axis? Where I required only one axis to define the nature of motion. Maximum height, the velocity becomes parallel. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. Continuing my discussion on motion in a plane. In the previous session, using the parallelogram law, I have derived a very important expression for the resultant and magnitude of two forces acting at a point. And also, as an assignment, I had asked you all to give me the expressions for the maximum value of that resultant and the minimum value of the resultant. In my today's class, we will have a clinical introduction to a very, very beautiful phenomenon called as projectile motion. So we will try to understand something called as projectile motion and its components in my today's class. So if you recall things that we did in our first class, we classified motion into three types based on a frame of reference. One-dimensional motion, which took place along a straight line, where I required only one axis to define the nature of motion. Maybe a car that is traveling in a straight line, a stone that is dropped from a certain height, etc. Two-dimensional motion, which took place in a plane, I required two of the three axes to describe motion there. An arrow shot into space, a football kicked into the plane, and finally three-dimensional motion where I required all the three axes. Example, a bird flying in the sky. So students, my today's discussion will gravitate around something called as projectile motion. Evidently, motion in a plane where I require two axes to define motion. So we will understand what is projectile motion and we will understand what are the components of the projectile motion. Now, I stand on a horizontal platform. Take a ball, apply some initial velocity and throw it into the space. I am taking a ball, I apply some initial velocity, I throw the ball into space. Here, I observe two kinds of motion. First, the ball will travel along y-axis. First, the ball will travel vertically. So, it will travel along y-axis vertically. I am taking the ball with some initial velocity. I throw it into space. The first motion observed is the vertical motion along y-axis. It reaches the maximum height and again it returns back to the horizontal. So if you observe here, the motion of the ball is defined initially along the y-axis. The ball initially defines vertical motion. Then along x-axis, horizontal motion. So I require two axes to define the motion of the ball. That is what is called as motion in a plane. Now, then what is a projectile? A projectile thrown into space, or I can say some object thrown into space. I am just throwing some object into space with some initial velocity. With some initial velocity, and that initial velocity is called velocity of projection. The velocity with which the object is thrown into space is called velocity of projection, and it makes an angle with the horizontal. The object is making some angle with the horizontal, and that angle is called angle of projection. And with all these components, the object thrown is called as a projectile. So, my dear students, what is a projectile? It should be an object that is thrown into space. It should have some initial velocity, and that velocity is called velocity of projection, and it should make an angle with the horizontal, that is called angle of projection, and this is what is called a projectile. Therefore, if you observe the figure here, so this is the x-axis, and the x-axis is called horizontal. The platform, the x-axis, horizontal axis, and y-axis, which is called the vertical. Observe, from the origin, I throw a body into space. First condition, what should I give? It should be given some velocity of projection. So U is called the velocity of projection. Now, first, the object is traveling along y-axis. It reaches some maximum height along y-axis and then comes back to the horizontal. So doing, it's defined some angle with the horizontal, and this is what is called a projectile. It is an object thrown into space. It has some initial velocity of projection, reaches maximum height, comes back to the horizontal, defines an angle theta with the horizontal, what I call as the angle of projection. Now, the path traveled by a projectile is called its trajectory. The path in which the projectile moves or the projectile travels is called its trajectory, and it is always a parabola. You have studied conic sections, ellipse, parabola, hyperbola. Mathematically next, I will give a proof to show that the trajectory of a projectile is a parabola. So if you see, this is the shape of the path traveled by the projectile, and it is parabolic in shape, inverted parabola. Now, the highest distance traveled by a projectile along y-axis is called maximum height of the projectile. So the maximum height, so this is the highest distance traveled by the projectile along y-axis vertically, and that highest distance is called maximum height. The highest distance, the peak distance covered by a projectile along the y-axis, vertical axis, is called maximum height, and the largest distance traveled by the projectile along the x-axis is called as the range. Nenpitkolli, the highest distance projectile covers along y-axis, the so-called highest distance or the peak distance is the maximum height, and the largest distance, maximum distance, it travels along the horizontal is called as the range of the projectile. Range andre some distance antalva. So range is the highest distance along horizontal. Maximum height is the highest distance along the vertical. Now, this is important. Please to follow. This initial velocity u is resolved into two components. I've taught you all yesterday. Resolving andreno, breaking down, split. I will split one component of this velocity along x-axis, that is horizontal, and one component along y-axis, that is vertical. Please to remember carefully, with respect to theta, with respect to theta, with respect to theta, I am emphasizing this, with respect to theta, component along horizontal is always cos theta. So what is split? Velocity. So what is its component along x-axis? U cos theta. Please to remember this resolution. Very important. Next year you have a derivation which is again based on this concept. With respect to theta, the component along horizontal is always cos theta, and along vertical is sin theta. So what is getting resolved? Velocity. So component of velocity along the x-axis horizontal is cos theta, and along y-axis vertical is u sin theta. Now, observe the path of the projectile, trajectory of the projectile. Somewhere at this point, again, this is the initial velocity. Again, resolution, u cos theta, u sin theta. Again, it reaches the maximum height. At maximum height, the velocity becomes parallel to what is called as the x-axis, u cos theta. Somewhere here again, this is along x-axis, u cos theta. This is u sin theta. My dear students, what I want to follow here carefully is, at any point of the projectile motion, horizontal component remains the same. See, at this point, horizontal component is u cos theta. Again here, u cos theta. Again here, u cos theta. Then what is varying? U sin theta with gravity. Please to understand, during projectile motion, vertical component changes with gravity, but horizontal component remains same. A very beautiful understanding. At any point, consider here, this is u cos theta again. Here it will be u sin theta. So anywhere on this parabola, which is defined as the trajectory of a projectile, u cos theta remains same. Horizontal component of velocity does not change with motion, but vertical component changes. That is a characteristic behavior of projectile motion. So very clearly we understood today that any object thrown into space, essentially with initial velocity, making an angle to the horizontal, is a projectile. Its trajectory is always referred to be a parabola. Maximum height it covers along the y-axis vertical is h max. Maximum distance along the horizontal is range. Resolve the initial velocity, u cos theta along x-axis, u sin theta along y-axis. Component of u cos theta remains same, but u sin theta changes with velocity. Next, students, I take up a task where I prove that the trajectory of a projectile is a parabola. Again, the same diagram. But before I creep into that, I want you all to refer to the session, go back to the understandings. Only then I can derive the mathematical equations. So next session, I'll take up this book work. Until then, have a nice time. Thank you.